Welcome folks, Rocky here. What I have for you today is the Carter Thermoquad carburetor. It's a 4-barrel design made for high performance engines. They made these, I believe, from the late 60s until about the mid 80s when fuel injection started to take over. Okay, this one here, quite different from most carburetors you're probably used to seeing. That's if you haven't seen one of these things before. What separates it mostly from most other carburetors is the center section here. Most are just made out of all aluminum or some kind of a metal. This one here actually has a float bowl made out of phenolic resin. This is supposed to, in theory, keep the fuel a lot cooler, so the power output would be greater. The bottom half of this thing, there's the throttle bores. I believe they made these in two different CFM configurations. This particular one looks like an 850 CFM model, probably off of a mid-70s Dodge truck with a 440 cubic inch engine in it. What separates the 800 CFM, I believe they made, to this one being an 850 CFM is the primary throttle bore. With the 800 it's only I believe it's an 1.25 inches or 1 3/8 diameter, whereas this one is 1.5 inches diameter. That makes this an 850 CFM carb, I believe. So you have 1.5 inches on the primary diameter. You have a whole whopping 2.25 inch diameter on the secondaries. Now, what makes a carb like this able to function on a smaller cubic inch engine, such as a small block with a, let's say a 340 cubic inch, is this air door. That's what separates most of the 4 barrels that have vacuum secondaries and make them able to run on a much smaller cubic inch engine. This one is quite different in the way the engineers designed it. The ventures here are actually curved. If you can see that when I push it down, right in there's these 2 dimples here, one on each side. And as they approach, as the engine starts to gain RPM and it starts demanding more fuel mixture, air and fuel mixture, the door starts to open up and it'll finally hit a stop if the engine's capable of pulling it that far. And as these dimples approach the secondary spray bars where the fuel comes out, it actually increases the venturi effect and you get a better draw off it, so it's more efficient than most designs that have the flat door on it. It's just got your typical choke on it, just a choke plate in the front. But this one is a divorce choke model. It does not have the coil wind-up spring on the side. The rod would just connect to this hole here, and it would actuate the choke linkage up here. There would be a divorce choke here with the thermostatic coil spring and a rod coming up to that hole. Okay, there's 2 functions to the choke pull-off. Normally most choke pull-offs, when they pull off, they actually just open the choke plate, say somewhere in the 3/16 or 1/4 inch area, right in here, this clearance. The additional function of the choke pull-off and its linkage, if I can get it centered, that is, under high vacuum condition, such as just cruising along or at idle, this will be fully retracted. There is a linkage that comes here which is missing, and it would actually pull this down. There's an arced slot in here which controls, that's a secondary, for the secondary air door. So under high vacuum condition it would keep that closed, and even if the bottom throttle plates were open, this would not start to come in until the vacuum started to drop, and this choke pull-off diaphragm would actually relax as the vacuum drops, enabling this to move here. So it's actually an initial regulator, probably helping the engine much as an accelerator pump would, by slowing the rate of opening. Say when you tromped on the throttle, it would slowly open, it would create a choke effect to feed richer mixture to get the engine going, otherwise you would have a lean bog. This is just going to be an introductory video for now. got the typical accelerator pump right in here. There's some adjustments here. You can bend things to adjust. There's a lockout here for the secondary. If the choke is on, there's a counterweight here, and it won't allow the secondary throttles to open up until the choke relaxes and comes down off the fast idle cam, and it will hook up here. So once the choke is off, then the secondary throttle bores would be allowed to grab and open up for you. But when the thing is cold, with this particular adjustment here, it won't allow you to use the secondary throttle at all until it warms up. This one is fairly basic. There's not much on it. On the front, you just got your typical idle mixture screws here and here, one for each side. You've got the ported vacuum that connects up to the distributor advance diaphragm, and this one appears to be for a positive crankcase ventilation hose. As we delve a little further into this, I'll probably be showing you a little bit more about adjustments and things to help it out, and maybe even a rebuild. But here's the serial number for this one. If you take the serial number, it shows a 6545S. Basically, the number you're looking for is a 6545. It can be found on the internet on various sites. You could actually look this number up and find out what application it was for. I'm pretty sure it'll come up as a Dodge with a 440 cubic inch, probably in the mid-70s, and it covered a few years. But like I say, this one is a very simple one because there isn't a lot of pollution control that would go with it. Another thing about this, while I think about it, is most of the primary metering rod functions are just strictly a spring inside and controlled by vacuum. When the vacuum drops, the spring overpowers the vacuum applied to it and allows the metering rods to come up out of the jets. With this one, it's quite different. You've actually put a little cam on the primary throttle shaft. Now if I can show you here, say you're just cruising along, city speed, vacuum's high, everything's good, you're down there. Most cars, when you tromp on it, the vacuum would drop, the spring would overcome the vacuum signal, and this would rise up just like that. Now in this one, it's actually on demand. You can actually force the metering rods out without even have to worry about vacuum. If you watch here, I'll hold it down with my finger, and I'll work the throttle linkage on the side. There's, like I say, once I take this apart sometime in the future, you'll be able to see the cam. But as I crank on the throttle, you can see that thing rising up and down, right? So it's actually a mechanical primary rod actuator. You don't have to wait for the vacuum to drop in order to richen the mixture on the primary side. So there you have it for today, folks. Hope you enjoyed what I had to show you. And perhaps in the future we'll start tearing this thing down and giving an internal view as to the things that are going on with it. Okay, bye for now. Take care and have a nice day.